Hi everyone, this is Ants. Today I'm going to show you a new project that I created called OpenVAT for Godot, which also includes an animated multi-mesh instance 3D support for OpenVAT solutions. And here's just a quick demonstration, and we're going to get into all this stuff after I explain what OpenVAT is. Okay, so OpenVAT is, and all you need to do is go to openvat.org. Here is the main site over here. What is OpenVAT? OpenVAT is a well-known Blender native toolkit for baking Vertex Animation Textures, and it allows pretty seamless integration into Unity and also Unreal Engine, and it has just a shader right now for Godot, and it doesn't support animation tracks, and you have to manually enter all the VAT configuration in terms of the min and max extents. It works, but it's not ideal solution, and it doesn't support animation tracks. So my plugin that I created builds upon this shader, and it actually is in plugin format, and it now allows you to support animation, support alpha, so you could fade in, fade out individual instances, and it makes it easy for the user to import the JSON file, set up the animation tracks, and it comes with an API to switch the animation tracks, change the alpha and all that kind of stuff. We're going to get through all the features it has, but it builds upon the current, it's just a shader right now. This site is really well done. It goes, if you don't know anything about Vertex Animation Textures, you could even learn from this. But and he has a really aggressive roadmap on the features that he's going to build, and he has a bunch of use cases. He shows the limitations, and he goes through all the technical details of what he's doing, and he goes into quite a bit of detail actually. And his solution only uses one Vertex Animation texture that is packed with both normals and Vertex data, right? So there's only one EXR file that you need, which reduces the amount of images you need to load to the GPU. And I guess there's going to be less texture binds and all that kind of stuff and everything. But let's go down. He goes through his feature roadmap. It's pretty aggressive, so he's making it better and better all the time. The project, let's go all the way down, all the way up, is, okay, so how do you download this toolkit in Blender? Well, there's multiple ways. Is you could go to just the official extensions here, and here is OpenVAT extension. It's been downloaded from this site 13,000 times. So as you can see, it's pretty well known. And also you could also download it from the GitHub repo, right? And the best way to load it is just to go to preferences and get extensions and type in OpenVAT, and it's over here. I've already installed it, but you would go here and just install it there. It's easy to install. So that's how you install it. You'll eventually get kind of a tool tab, and I'm not going to go into detail how to use OpenVAT. And the reason why I'm not going to go through it is because the actual author of OpenVAT, his name is Luke Stilson. He has 11 videos of talking about OpenVAT. I mean, he basically goes through this in detail, and he has all the different use cases. So if you want to learn how to use OpenVAT in Blender, just watch his videos, and I'll link his channel in the description. He has a bunch of shorts too, of cool stuff. But anyways, so that's OpenVAT. Why is it great? Well, it's open source. It supports multiple engines, which is a good thing because it means it's used by a lot of people, right? And you know, if Unreal Engine users are using it and Unity users are using it, that's a good thing for Godot too, because it does support Godot, and my plugin adds to that support, and it makes it easy to import everything. Okay, so hopefully I communicated to you that OpenVAT is kind of like the Blender toolkit that you should be using for Vertex Animation Textures in Blender, and export it from Blender and import it using my tool. Okay, so let's go back to Blender. And so I have K's mage here, and I just strung together a couple of strips into one action. I combined them, and it will export whatever animation is playing. Okay, so what happens here is there's a couple of things that goes on. Is when you click on encode Vertex Animation Textures, it will generate 3 files. We're going to go over 3 files, but one of the files is a new model with collapsed geometry into one mesh. So it automatically generates a collapsed mesh, and that's one of the 3 files it generates. The other thing it's going to generate is a JSON file, and it's going to encode the min and max extents of this Vertex Animation Textures. I don't want to get into detail why that's important. It basically tells the shader, you know, what are the extents that the animation takes place, and that helps on precision and a bunch of other things. The other file is the packed vertex and normal over here, packed vertex and normal texture, and those are the 3 things that it produces. Okay, and all you do is click on encode Vertex Animation Textures, and it generates them. The only thing that you need to remember with Godot is you always have to select packed vertex normals. You have to export to GLTF binary format, so GLB. That's the only format that's supported currently with Godot. And the other thing is use single row. You have to select use single row. The other thing is right now you have to fill in these animation tracks manually, but he has a feature where he's going to automatically, you just select which tracks you want to, which actions you want to concatenate, and he's going to automatically populate the animation data and the animations strips into one action, and he's going to export. Like I said, he's discussed it on GitHub. I don't know when he's going to do it, but right now you have to do it manually, which is not a big deal. Basically, you do everything in Blender, and you set up all the metadata in Blender, and that's good. It separates the developer role from the animator role too, right? So even in larger teams, this is actually better. Anyways, you encode where it is, the Vertex Animation Texture, and you get 3 files. So now we're going to talk about, so we're going to take a break, and we're going to talk about the Godot side and my plugin and how to use it. So that's probably what you guys want to see next. So let's start with that. Okay. So we're going to go to Godot here, and I've created on my assets folder a mage folder here, and I'm going to copy the files that were generated, and it's 3 files, and then we're going to go through them. And I just dragged and dropped them right now. The first file, which is probably very important, is the JSON file. And as you can see, it's pretty simple. It has all the animations in the metadata. It has number of frames, but we don't really need that because we could actually calculate that in the shader, how many frames it is. But this is important. The min and max vector 3s of the extents of the Vertex Animation Textures, right? And this is going to be auto imported. So I'm just showing you what the file is so that you know what's going behind the scenes, but you don't have to know anything about this JSON file if you really don't want to. The other thing that it generates is the GLB, the binary GLTF, and it creates a single mesh of your model. This is just a single mesh, and we need to export this as a file, and we also don't need LODs. So we have to enable save the file, and we have to select where to dump it. Go to assets, mage, and let's type mage _ mesh, and let's make it a resource, and we save, and then we re-import, and now we got a mage mesh. Okay, now we're going to attach my updated shader to this mesh because it's a Vertex Animation Texture. The magic happens in the shader. So we're going to go to surface 0 and change the material to a shader material, and we're going to load my shader, and it's in the add-on, and I have to show you how to install the add-on. Remind me. Go to shaders, and there's two shaders. One is the original shader, which is just the singleton shader, and this is the instance shader here. So you have to use the instance shader, right? And now you have a bunch of shader parameters over here. First thing we need to do is copy over the Vertex Animation Texture that was generated. That's the third file, right? Here it is. And the first part are the normals and the vertices. They're packed on this, or maybe it's the reverse. And the min and max values, you don't have to change, and you should change the speed to the same FPS as in Blender. This one is 24, and that's basically it. I didn't check one thing, but I did it on purpose because I'm sure people are going to go through the same thing and say, whoa, this doesn't look right. So anyways, everything's basically done on the mesh. Make sure you save the mesh, right? So the mesh is set up. Now we could use the plugin. And if you go to project settings, plugins, here is my plugin, OpenVAT Animated Multi-Mesh Instance 3D. I add a new node called OpenVAT Multi-Mesh Instance 3D, and so we're going to add that. And don't worry, in the description, I'll show you where the GitHub repository is of my plugin. And as you can see, there's an OpenVAT Multi-Mesh Instance 3D. Let's select that. If we go to the warnings, it says, hey, no exported mesh assigned and no OpenVAT JSON file assigned. Where do I do that? Oh, it's over here. It's actually quite good, and there's documentation that I added. So, there's that. And let's go to 3D because this is a 3D scene. So all we need to do is that mesh that we configured, you just drag and drop it in. We could change the instance count because this is a multi-mesh instance 3D. And we have to assign it the JSON config file. So we drag and drop the JSON file, right? And the first time you do it, you should manually import it, right? And as you can see, it parsed the JSON. It got the min and max values, right? And it set up the animation tracks, okay? You don't have to do this all the time, but right now it's set up so that on ready, so on instantiation of this node on ready, it will automatically re-import the JSON file that's been assigned. And the reason why I did it is because sometimes I updated the JSON file and I didn't update the import, and it was using the old value. So this solves it. It just does it on ready, and it parses it. It's extremely quick, 2 milliseconds, but it saves a lot of headaches in terms of syncing and all that kind of stuff. Okay, so everything's done. It's done. And so let's run this. There will be a small problem, but I did it on purpose because everybody is, oh yeah, there's two problems actually. One is we didn't assign any albedo textures or normals or metallic, all that kind of stuff. There's only a texture. And the other thing is it doesn't look like the mesh is correct. And there's a reason why. The reason is this exe file by default is imported as VRAM compressed, and it loses precision. So you have to change it to lossless, and you could remove the generate bitmaps. You don't have to generate bitmaps, but you have to select the compress mode to lossless. It cannot be compressed because you lose precision, and then it doesn't look good as you saw when you run it. So we're going to re-import that. So that fixes one problem. Then we got to go back to the mesh, and we forgot to do the PBR stuff. So it supports all the PBR stuff, physics-based rendering. So it does the albedo. So this is a low poly K-kit model. It only comes with albedo texture. And if you had a metallic texture, you could change specular, roughness, the normal. You could do all that. You could add it if your model does have it. So now, let's save that again. Now it will work. So let's play it again. And there you go. So this is also doing an alpha test. If you notice, they're fading out. And it's just... the empty scene is that type of scene. So everything looks good. Every different one has a different track. It just goes from attack, spin, run, cheer. Attack, spin, run, cheer. Attack, spin, run, cheer. And now it fades out all of them, and now they're going to fade back in, back at the back. As you can see, back here, they're fading back in. So it looks pretty good. It didn't take long. I know we went through everything. By the way, my GitHub repo goes through this step by step in detail, and it's going to point to this video, this section of the video. And it looked like it was a lot of work, but it actually is not. Once you have the mesh set up, you could reuse that mesh on multiple OpenVAT multi-mesh instance 3D, and you don't have to do anything. You just have to import your JSON file. I mean, that's all you need to do. It's actually quite easy. And that's basically it, right? Okay. So let's go through the demos that are going to be included in the project and why they're important and everything. So let's stop this. Okay. Let's run the demo. So this is just one animation track, and there's two overlapping here. That's why it looks weird. So let's play it again because it just does it random size. Yeah, it's still overlap there, and there's overlaps over here. But anyways, this is just one mesh, and it's instance, and they're all playing the same animation, Vertex Animation, but with slightly different randomized offsets. So that's why it looks like they're all kind of different, but they're all basically the same. And the deform happened in Blender, and it just exported and that sort of thing. And there's 200 instances here. This is a perfect loop cloth demo. Now, any cloth simulation that you could do in Blender, like a cloth falling down on a sphere or an object or whatever, anything that you could do in Blender, you could export as a Vertex Animation Texture using OpenVAT. The only limitation is the number of vertices have to remain constant and has to be less than 8,192 vertices, and the number of frames has to be less than 4,096. That is actually a lot of frames, because if it's 60 frames a second, and you don't really need 60 frames a second, right? You could get away with 30, but let's just say it's 60. 60 times 60 seconds is 3,600, which is still less than 4,096. What I'm trying to get at is you could put over a minute worth of animation of 60 frames a second animation and encode that. So it's pretty good. This is a performance test. This is 2,000 instances of a skeleton, and there's a spin, walk, death, cheer, and like a twerking, like this thing, I don't know what it is, or it's staring you down, I don't know what it is, like this guy over here. And yeah, so you could crank this up to 5,000, and it still does hundreds of FPS. Shadows really do impact performance. So just keep that in mind. And also MSAA2 is on. If you want better performance, turn off MSAA also if you want better performance, right? So just keep that in mind. Next demo, this is just a simple deformed single instance jello. This is using the bare bones, out of the box OpenVAT Godot shader. And you have to manually put the extents in, but it's a single instance. You don't have to use the multi-mesh, mesh shader. You could just use the one that comes with OpenVAT. And this is basically an OpenVAT shader test. This is the alpha test. You've seen this before with the Mage, but it's included in the demo project. This demo here is a multi-mesh instance. There's only one instance, but it's testing all the animations, and it changes the camera so that you could see it, right? So it's changing the animation every 3 seconds, I think. 1, 2, 3, or every 5 seconds. 1, 2, 3, 4, 5. I think it's 5 seconds. So this is a good test to just basically see if your animations are working. And by the way, the change of the animation is happening through an API, right? So every 5 seconds, the API is saying, play next track, play next track. This was a Blender demo that used shape keys and bone driving this animation. And I wanted to see if it actually worked and converted into a really good VAT animation, and it did. It actually looks really, really good. No folds, everything's smooth, that sort of thing. So that's basically it. Okay, so let's go to my repository, which is over here. Right now it's still private, but again, I'm doing a lot of testing. I'm trying to update the documentation, right? Okay. So I don't know what to call it. OpenVAT for Godot. I think that's what I'm going to go with. So OpenVAT for Godot plus it includes an animated multi-mesh instance 3D support. So you could add thousands of Vertex Animation instances with all playing their own animation track. And you could also fade in and fade out, right? And again, this is just a preview. So it's documented pretty well, right? How to install the plugin. I talk about the new OpenVAT multi-mesh instance 3D. This is the most important, this is probably the hardest thing to do, right? Other than using OpenVAT Blender tool, is preparing your mesh for the OpenVAT multi-mesh instance 3D, right? And I go through that step, and I just showed you in the video, and I'm gonna link that portion of the video over here. And then the properties, once you get to the OpenVAT multi-mesh 3D, this is easy. You just copy and paste the mesh, change the instant count, and import your JSON, and make sure you're pointing to the correct JSON file. It updates the min-max values, it updates the animation tracks, and that sort of thing, right? And then it imports it. So then there's the functions, right? Per instance, you could change the track. Per instance, you could change the alpha. Per instance, you could change the animation offset. What is the animation offset? If you want 1,000 skeletons all to be walking around, they shouldn't be walking around in lockstep and synchronized. What you should do is change the animation offset of each one and just give it a value, a random value between 0 and 1. And so it will actually start its animation with a different frame. So they'll all look like they're walking around, but they're all walking out of, they're not in kind of synchronized. They're unsynchronized, and it actually makes it look really, really well. This one here updates a specific instance offset, track number, and alpha all within one call. So again, this call here is basically calling these individual ones. You could update all instances with all track numbers and alpha and all that. Like I have a lot of really useful kind of versions of doing kind of the same thing. You could do all instances, individual instance, alpha, track number, offset. You could also do play next track for an instance ID or play next track for all instances. Easy, boom, done, right? Then there's a bunch of, sometimes the most important thing here is sometimes you want to know, given this instance that just got hit and it needs to die and play the death animation, I need to know the current track it's playing. Or sometimes you need to know what the current instance track is playing, right? And so I have a bunch of different functions like get track number from the animation, get animation from the instance, or get track number from the instance. Sometimes you only know the start and end frame, so you could get the track number from the start and end frame. Like there's a lot of different things you can do, right? So what I'm trying to say is this API is a pretty, it covers a lot of kind of different scenarios. And if you come up with new kind of like, hey, it would be really nice if you could give me this information in an API call, just let me know and I could add it. I'm pretty sure I can add it within a couple days. Okay, so that's basically it. I hope you enjoyed it, and let's just go back and play this again. So this is OpenVAT for Godot. It allows you to use the OpenVAT Blender Toolkit and export it and then import it easily into Godot, and it will import the min and max extents and also the animation tracks, and it adds additional functionality. It gives you a new version of the multi-mesh instance 3D that allows you to import the JSON file very easily. It gives you individual alpha support for all instances. You could change track on all instances. It gives you animation track capability to the multi-mesh instance 3D based on the OpenVAT Blender Toolkit. And OpenVAT is probably the best tool to support Vertex Animation Textures for Godot, because it has support for all the other mainstream engines, which means it's used a lot and it's supported. And I really like that he has a really good features roadmap. So we could see some really interesting things come out of this. So this is the reason why I based my solution on that. So thank you for watching, and hopefully you found this useful, and take care of yourself. Bye.